So this is 3.4 problem set. So we're going to look at 19. They're saying that the radius is 6 centimeters. Our omega, or angular velocity, is pi over 3 radians per second. And our time is 9 seconds. And in the instructions, they're even giving you the formula. They say use the formula S equals R omega t to find the value of the missing variable. So for 19, we're just going to put 6 pi over 3, 9, and that will give us our distance. That'll give us our S. Okay? So they use the formula omega equals theta over t, and they rewrote this as theta equals omega times t. And instead of using theta in the formula S equals R theta, they used WT. So that's where they got the formula S equals RW, or omega t. So anyway, use those for 19 through 24. Okay, let's do number 39. Okay, we've got a pulley shown. It has a radius of 12.96, and suppose that it takes 18 seconds for 56 centimeters of belt to go around the pulley. So let's say that this is going around and it's pulling this belt here this way. And it takes 18 seconds for this pulley to suck up 56 centimeters of belt. Okay, so that's what we're given. So let's say it goes from here all the way around to, who knows, let's say here in 18 seconds. And this is 56 centimeters of belt that it pulls onto itself. Okay, so that's what it's doing. First thing we're doing is finding angular speed in radians per second. The next thing we're doing is finding the linear speed in centimeters per second. So this we're finding distance, centimeters. This we're finding angle, how fast this angle is growing per second. So that's what we're doing here. So let's look at what we've got. So here is angular velocity, angular speed. Omega equals theta over t. The problem is we know nothing about theta. It doesn't give us anything about an angle in any way whatsoever. So we can't use this formula because we haven't gotten anything. So I look back and see, okay, what other formulas do I have? If you look down at the bottom of page 117, you got a couple other formulas. We have a velocity equals r times omega. Okay, so we are given a velocity. We are given a velocity because velocity is distance over time, right? So we have 56 centimeters over 18 seconds. That's our velocity. And we also know a radius, don't we? 12.96. What we don't know is our omega. So if we put that formula in there, we can find our omega, and I find that our omega, if we do the math, is going to be 0.24 radians per second. Okay, so see how I had to kind of go through the back door to get this. I wasn't able to use this formula because I wasn't given anything about the angle. But by giving me a distance over time, it was giving me a velocity. So I used the velocity formula. So you can look on the bottom of page 117 and get all the different formulas you need. I would put those down in your notes so that you have them handy, so that you can look and see what you've got, what you're looking for, and where you're going to get it. And then that gave us our omega then of 0.24 radians per second. Okay, so what does the B portion of this ask for? We're looking for linear speed here. All right, so if you remember, we've got linear speed, And let's see, linear speed, we've got 3 different options there for linear speed. And I am going to use v equals s over t. And the reason for that is because my s is my 56 centimeters. That's how long this rope went around here. I mean, because that's always going to be my s. So I had that. And I also have 18. So that's my velocity. So this really is a pretty simple part, this B part. It's just the distance that I traveled over time, and I'm going to reduce that to 28 over 9 and just divide that out and get 3.11 centimeters per second. So that's how fast that belt is traveling around this outside part of the circle here, is 3.11 centimeters per second. Alright, so that was number, what did I say, 39. And the rest of them are very typical. I mean, you've just got to remember, especially to look back at the formulas on the bottom of page 117, write them down just like that, so that you can refer back to them, because you're going to use one of those. I mean, obviously angular speed, there's only one formula you're going to use there on the left, but if you need to find omega, you can use one of the linear speed formulas on the right. Well, the bottom one particular, v equals radius times omega. So if you're given the radius and velocity, then you can find omega, plug it in, and be able to find maybe theta in the angular speed. If you've discovered omega in time, then you've got theta there on the top that you can use. So hopefully that'll help you in 3.4 problems.